Hello friends, myself R.D. Mahajan presenting my video on Laplace Transform Revision Part 2. In continuation with the previous part, let us try to solve the problem. Point evaluation of integral by Laplace Transform. Evaluate integral from 0 to infinity of e raised to minus t sine of root 3t divided by t and its integration with respect to t. And whenever we have to evaluate any integral by Laplace transform, we try to convert this into elementary definition of Laplace transform. Therefore, let consider the given integral as I. It is integration from 0 to infinity of e raised to minus t sine of root 3t divided by t and its integration with respect to t, as we rewrite that as integral from 0 to infinity. This e raised to minus t term with e raised to minus st into remaining term as it is, that is sine of root 3 times t divided by t and its integration with respect to t, where s is equals to 1. Therefore, if we put s is equals to 1, we get once again that term e raised to minus t. Means this integral we are converting in the form of standard result or the elementary result of Laplace transform. And as per definition of Laplace transform, this term is nothing but Laplace transform of sine of root 3t divided by t. And to obtain this Laplace transform, if we call this as equation 1, we have to obtain first Laplace of sine of root 3 into t. We know that Laplace transform of sine of root 3 times t, sine of at, as a upon s square plus a square, as per that formula, it is root 3 divided by s square plus root 3 square and we call this as a bar of s. We apply the property of division by t, or theorem f of t by t. As per that theorem, therefore, Laplace transform of that sine root 3 times t divided by t, applying that theorem, it is nothing but integration from s to infinity of f bar of s and its integration with respect to s. Therefore, it is integration from s to infinity root 3 divided by s square plus root 3 whole square and its integration with respect to s. It is equals to root 3 constant term we take outside the integral sign. Integration of 1 upon x square plus a square, it is standard result. It is 1 by root 3 tan inverse of s by a, s by root 3, and limits from s to infinity. Root 3 get cancelled. Subtracting the upper and lower limit, it becomes, for upper limit it becomes tan inverse of infinity minus, for lower limit s replaced by s, we get tan inverse of s by root 3. But tan inverse of infinity, we know the standard result or standard value for that as pi by 2 minus tan inverse of s by root 3 pi by 2 minus tan inverse theta is nothing but cot inverse, and therefore it becomes cot inverse of s by root 3 and then at s is equals to 1, at s is equals to 1, that integral becomes I is equal to, put s is equals to 1 here, it becomes cot inverse of 1 by root 3 as the answer, or the value of that definite integral by Laplace transform technique. Remember only this part, replace that e raised to minus t by e raised to minus st, and whatever that value write down for s. Here we have the coefficient of t as 1, and therefore we consider s as 1. And then applying the definition of, or the properties of Laplace, try to get the value of this Laplace transform. Second example, find Laplace transform of integral from 0 to t of t e raised to minus 4t sine of 3t dt. This problem containing 1, 2, 3, 4 terms of the properties we have to apply. First we go from right to left direction. Means first we find the Laplace of sine 3t, then we apply the property of multiplication by t, then first shifting theorem, as we have the term of e raised to minus 4t, and finally Laplace of integral. Therefore it is a combination of more than one property for Laplace transform. Therefore we go step by step. Therefore remember the steps, then and then only you can solve such type of problems. We write down Laplace of sine 3t first. It is a upon s square plus a square. A is here 3, therefore it is 3 upon s square plus 3 square. 3 square is 9. Therefore we call this as a bar of s. Then we multiply it by t, and therefore applying that property multiplication by t raised to n, therefore Laplace transform of t into sine of 3t. We have to perform step by step, write clearly all the steps. Therefore as per that theorem it is minus 1 raised to n power is here 1, therefore minus 1 raised to 1, minus 1 raised to 1, same order derivative with respect to s of f bar of s, and therefore it is minus sine minus 1 raised to 1 is minus d by ds of f bar of s. F bar of s is here 3 upon s square plus 9. Differentiating this term with respect to s, it is somewhat similar to 1 by x type of term. Its derivative is minus 1 by x square, therefore minus s square plus 9 whole square. Applying chain rule, differentiation of s square with respect to s is 2s, and therefore that becomes minus minus, it becomes plus 2s whole divided by s square plus 9 whole square. We call this a new f bar of s. Then we apply that first shifting theorem by applying first shifting theorem. Laplace transform of t sine 3t. This function is multiplied by e raised to minus 4t. By first shifting theorem, we have to replace s by s plus a, as here we have minus 4 e raised to minus 4t, and therefore it is a bar of s plus 4. Wherever s is there, replace s by s plus 4 to get the Laplace of this, and therefore it becomes 2 times s plus 4 whole divided by s plus 4 whole square plus 9, and that bracket raised to 2, and we call again a new f bar of s. Therefore 1, second Third step I have completed. And then finally, therefore, Laplace of that integral. Therefore, Laplace transform of integration from 0 to t of t e raised to minus 4t into sine 3t and dt. As per this theorem, Laplace of integration, it is 1 by s into f bar of s. Therefore, whatever this previous f bar of s or latest f bar of s, we have to multiply it by 1 by s. Therefore, we get value of this Laplace transform as 1 by s into f bar of s is 2 times s plus 4 whole divided by s plus 4 whole square plus 9 that bracket square, and outer bracket we take as a curly bracket. Therefore, that final answer is 1 by s multiplied by 2 times s plus 4 divided by s plus 4 whole square bracket square plus 9 and this bracket square. We call that as the answer for this Laplace transform or the value of Laplace transform. Therefore, see the steps. Whenever we have to evaluate such type of Laplace transform, consider the direction, it is from right to left. Means first we find the Laplace of sine 3t, then we take the help of that Laplace of multiplication by t raised to n, then we are applying first shifting theorem, and finally Laplace transform of integral. Means 1, 2, 3 theorems we have to apply to find out the Laplace transform of the given function. Example number 3rd, find Laplace transform of e raised to minus 4t into integration from 0 to t of t sine 3t with respect to t. Here also a combination of more than one property. Therefore, once again we go from right to left direction. First find the Laplace of sine 3t, then apply the property of multiplication by t, then Laplace of integral, and then finally a first shifting theorem. See the difference between the previous example and this example. In the previous example, that e raised to term is inside that integral sign. That's why we are applying last property of Laplace of integral, and here last one is first shifting theorem. Try to see the basic difference between these two examples. Don't make any type of confusion. And therefore, first we go for Laplace of sine 3t. It is a upon s square plus a square. A is here 3, s square plus 3 square 9. We call this as f bar of s. Say, then multiplication by t property. Therefore, as per that, Laplace transform of t into sine of 3t. Applying that theorem, it is minus 1 raised to n, n is here 1. Therefore, minus 1 raised to 1. D by ds of f bar of s, same order derivative, means first order derivative. Substitute value, therefore minus d by ds of 3 upon s square plus 9, it is minus, again 1 by x is derivative is minus 1 by x square, as per that it becomes minus 3 upon s square plus 9 whole square. Chain rule, differentiation of s square is 2s. Simplifying it, minus minus it becomes plus 6s whole divided by s square plus 9 whole square, a new f bar of s. Here two steps are completed. I have completed first two steps. Then Laplace of integral. Therefore, Laplace transform of integral from 0 to t of t sine of 3t and its integration with respect to t. As per that theorem, it is 1 by s into f bar of s, and therefore it is 1 by s into f bar of s. F bar of s is here 6s whole divided by s square plus 9 bracket square. SS get cancelled. We get that value as 6 divided by s square plus 9 whole square, and we call this as new f bar of s. Every time I am calling it as a new f bar of s. And then final step, it is multiplied by e raised to minus 4t, means it is a problem of first shifting theorem. Therefore, applying that first shifting theorem by first shifting theorem, FST. Full form is first shifting theorem. Laplace transform of e raised to minus 4t integral from 0 to t of t sin 3t dt is equals to, as per that first shifting theorem, whatever the last f bar of s, Laplace transform, replace s by, here it is e raised to minus 4t, replace s by s plus 4. Therefore, it is f bar of s plus 4. And then replacing s by s plus 4 in this last step or the previous step, we get that value as 6 divided by s plus 4 whole square plus 9 bracket square as answer, or the Laplace transform, required Laplace transform. Therefore, see the steps once again. First, I have obtained the value of Laplace of sin 3t. Then I have applied Laplace of f of t into t raised to n property or theorem. Then Laplace of integral property or theorem. And then finally first shifting theorem. To get this final answer, 6 divided by s plus 4 whole square plus 9 that bracket square. Next point, a Laplace transform of periodic function. First of all, I will define what is my periodic function. If we have f of t plus capital T is equals to f of t, then that t is called as a period. Means after some equal interval, if the same cycle is repeated, then that type of function is called as a periodic function. And if that function is a periodic, its Laplace transform is given by or obtained by 1 upon 1 minus e raised to minus s into capital T, integral from 0 to capital T of e raised to minus st, here t is small, f of t dt. Two types of t, small t and capital T, where that capital T stands for the period of that periodic function. First example, find Laplace transform of f of t if f of t is plus k between 0 to a and second value as minus k between a to 2a, with the condition f of t plus 2a is equals to f of t. Though that word is not appeared here, that is function is periodic function, using this condition we can say that it is a periodic function, as we are getting this f of t plus capital T equal to f of t. Same cycles are repeated after every 2a, and therefore with the help of this condition we get the value of t capital T as 2a as a period of that periodic function. Then applying the formula, therefore the Laplace transform of f of t, when f of t is a periodic function, it is 1 upon 1 minus e raised to minus st, capital T is here 2a, therefore it becomes minus 2as. Integral from 0 to capital T, 0 to 2a. 0 to 2 is not a continuous range, therefore we keep this term e raised to minus st into f of t as it is. I am not substituting the value at this stage. Then we split this as per this. It is 0 to a and a to 2a. Next step, therefore it is 1 upon 1 minus e raised to minus as and bracket square. That nothing but e raised to minus 2as. Then we split that integral as 0 to a and then a to 2a. In between 0 to a, the value of that function is k, therefore f of t is k here into e raised to minus st with respect to t. Between a to 2a, the value is minus k into e raised to minus st. From these two terms, I can take k common as it is a constant term. Therefore, it is k divided by 1 minus e raised to minus as. Integrating this e raised to minus st with respect to t, we get integration as e raised to minus st by minus s. Limit from 0 to a, then minus sign. Again, integration of e raised to minus st is e raised to minus st divided by minus s, and limit from a to 2a. Substituting the upper and lower limit for this two terms, we get that value as k upon 1 minus e raised to minus as whole square of, I will cancel that minus sign by changing the limit, therefore it is e raised to 0 as 1 minus e raised to minus as divided by s, then minus minus will become plus. Again upper limit e raised to minus 2as minus lower limit e raised to minus as whole divided by s. Same denominator, therefore adding the numerator terms we get, or finding LCM, it is equal to k upon, it is a square minus b square, factors are a plus b and a minus b, therefore the factors of this term are 1 plus e raised to minus as into 1 minus e raised to minus as into a square minus 2ab plus b square is a perfect square of a minus b, and therefore it is nothing but 1 minus e raised to minus as bracket square whole divided by s. So that this 1 minus e raised to minus as cancel with one term, and finally we get k into 1 minus e raised to minus as whole divided by 1 plus e raised to minus as into s as the required Laplace transform or answer. One more I will discuss. Second, find Laplace of f of t. Here f of t is not provided, it is represented in terms of figure as shown in the figure. And the given condition is f of t plus 2 is equals to f of t. Means it is a periodic function with period t as 2. Therefore capital T as 2 here. Then as it is periodic function, we try to apply the formula to find the Laplace of periodic function. there are two different functions. In between 0 to 1, we have a straight line as the first part of that function, and between 1 to 2, another straight line, that is x-axis. And therefore, we try to determine the equation of that f of t in between 0 to 1. Points are here, origin 0, 0, second point is 1, 1, line passing through origin. Therefore, we try to find out the slope of the straight line, y2 minus y1, that is 1 minus 0, we get 1, divided by x2 minus x1, again 1 minus 0, we get 1. Therefore, slope is 1. And equation is y equal to mx. M is here 1 and x means t. And the condition 0 less than or equal to t less than or equals to 1. In between 0 to 1, we get that function as y is equal to t. The second value of the function is here x-axis, equation is 0 between 1 to 2. Therefore, with the help of figure, first step is where to obtain the equation. And then try to get the Laplace transform. Therefore, Laplace of f of t, periodic function f of t, as 1 upon 1 minus e raised to minus st. Capital T is here 2. Therefore, 1 minus e raised to minus 2s into integral from 0 to t, 0 to 2, e raised to minus st into f of t dt. Applying that formula. And as it is not a continuous range, we have to split this integral as 0 to 1 and 1 to 2. And therefore, it is 1 upon 1 minus e raised to minus 2s splitting this integral as 0 to 1 and then 1 to 2. Between 0 to 1, the value is t into e raised to minus st and its integration with respect to t. Second value is 0, therefore it is 0 into e raised to minus st. As this term is 0, this term becomes 0. Then performing the integration by generalized part, as we have product of two terms of t. Therefore, integrating by generalized part, 1 minus e raised to minus 2s t algebraic term, e raised to minus st is exponential term. Therefore, as per that order, LIATE, algebraic comes first. Therefore, we consider the first term as t. Integration of the second term, integration of e raised to minus st is e raised to minus st by minus s, then minus terms alternately positive, negative. Derivative of t with respect to t is 1 into next integration of this term. Its integration is e raised to minus st upon minus s, and this previous minus s, it becomes s square. Next plus derivative of constant term, it is 0, we stop here and limit from 0 to 1. Substituting upper and lower limit, therefore first we put t as 1, small t as 1, therefore it is 1 by 1 minus e raised to minus 2s 1 e raised to minus s upon minus s minus e raised to minus st, t is 1, therefore again e raised to minus s by s square minus lower limit, for t equal to 0, this term becomes 0, minus e raised to 0, it is 1 by s square. Then collecting these two terms of s square in one bracket, keeping this as it is, we get that result as 1/1 minus e raised to minus 12 this is minus minus plus 1 minus e raised to minus s whole divided by s square and minus e raised to minus s by s. As answer, in my next video, I will revise inverse Laplace transform. For that also, I will discuss in two parts, part 1 and part 2. Therefore, if you like my video, please share it as well as subscribe to my channel. To receive the notification, you have to press the bell icon. Thank you. Thanks for watching.